so now we're going to do number 2 on the worksheet, which is PCl3. So again, you're always going to be given the formula. Look at the subscripts. According to the subscripts, I have 1 phosphorus and 3 chlorines. That's important that you see that. And then it shows you that the number of single bonds is 3. And then there's no double, no triple. So you're going to have all single lines here. First task you guys have is to figure out the number of valence. And then the second task is going to be to figure out the central atom. So to do the number of valence, I'm going to show you the work right down here. You're going to write down the elements. So you're just copying it down right from up here. So I'm going to write a P, and then I'm going to write a Cl with a 3. You're going to bring the subscript down when you write the element because then you'll forget. You'll forget the subscripts there if you don't write it here. I'm going to use my periodic table, find phosphorus, and find that it is in column or group 5A. I'm going to find chlorine and figure out that it's in 7A. It's just what group it's in. So that means the phosphorus atom has 5 valence electrons. The chlorine atom has 7 valence electrons. Multiply by the subscripts. Phosphorus does not have one, so you don't multiply by anything. Chlorine has a subscript of 3. So I'm going to multiply 7 times 3 to get 21. To get the total, I'm going to add 5 and 21 to get 26. So this picture, either in dots or lines, should show 26 valence electrons. So that's what I'm going to write up here on the valence, 26. Then to figure out the central atom closest to carbon, the one closest to the mothership carbon, out of phosphorus or chlorine, phosphorus is closer. So your central atom is going to be phosphorus. If you notice as well, usually the one in the center is the single one, and the terminal are the ones that have more than one, the subscript on them. So now, at this point, I know I'm going to draw a structure with phosphorus in the middle. I'm going to connect chlorines, 3 of them, using 3 single lines, and I'm going to check to make sure it has the right number of valence electrons. So the most logical way to do that is put phosphorus in the middle, use lines to connect the chlorines. You need 3 of them. Remember, everything wants to be even, Steven? At this point, it doesn't really matter if you put the chlorine on top or bottom. Either one's correct, just as long as you only put 3 chlorines, not 4, because you only have 3. So right now I'm showing 1 phosphorus, 3 chlorines. Good. My formula's good. Phosphorus is in the middle. I'm showing 3 single bonds. Good, good, good. The last thing I have to check for is the number of valence electrons, that 26 that we figured out. Count what you have. Maybe you have it. Right now I'm showing 3 single bonds. Each represents 2 electrons, so I'm only showing 2, 4, 6 valence, so I have a problem. I got to add more, right? When you add electrons to the picture, you do it with dots, not lines, because a line represents a bond. Now, where do the dots go? The octet rule helps you figure out where the dots go. The octet rule is that every element wants 8. Remember that these bonds belong to both. So when I count them for both. So right now, if I look at chlorine, this bond is attached to chlorine, which means there's 2 electrons with chlorine right now. That's not good. Chlorine wants 8. So to fulfill the octet rule, just like when we did dot structures, I'm going to draw 6 dots in like pairs, 6 dots in 3 pairs. So now the chlorine has 2, 4, 6, 8. I'm going to repeat that with all the chlorine. So I'm going to draw 6 dots around all the chlorine atoms. And when I do that, every chlorine atom has 8 valence electrons. Now, make sure I have the right total. Because remember, I need 26. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I'm still missing 2. But if I look, phosphorus only has 2, 4, 6, so it needs 2 more. And that'll give me everything even Steven the way it's supposed to be. I'm showing 26 valence. I'm showing all my elements. Everything has an octet rule of 8. Everything's good.